A 10 microcoulomb charge moves with a velocity of 1 times 10 raised to power 5 meter per second at right angle to a magnetic field of flux density 5 times 10 raised to power minus 4 Tesla. Calculate the force on the charge. So for us to start this, I want us to first of all write what we are given in the question. So I'll say given. The first thing we are given there is the charge. Charge is given by letter Q. Let me use small letter Q is equal to 10 micro. This symbol means micro, and then the unit of charge is coulomb. And 10 micro is represented as 10, that is this value 10, multiplied by this micro means 10 raised to power minus 6 is a small value representing 10 raised to power minus 6 coulomb. So this 10 micro, anytime you see micro attached to a unit, just multiply that value by 10 raised to power minus 6, and that will give you the original value for that quantity. And then now the next thing we are given the magnetic field, and that is given to us as letter B. Magnetic field is represented as VB, that is the magnetic flux density. And that will be 5 times 10 raised to power minus 4 Tesla. So this is the magnetic field strength or density. Now, we are also asked to calculate the force. So after writing everything given to us in the question, we have to write out the force. And that is F that we are looking for. F is equal to question mark. Please don't forget, in this question, we are told that it is at right angle to the field. So when we are saying at right angle to the field, there's no need of putting theta in the question, because the value of sine 90, right angle means 90, sine 90 will give us 1. So there's no need of putting that value, that theta, in the given parameters. So right now, the formula we are going to apply in solving this question is a direct formula, and that formula is given by F is equal to B V Q. There's no need of putting sine theta because we already have right angle in the question. So when there's right angle, there's no need of putting sine theta in the formula. So I can now substitute the values given to us in the question. So B is the magnetic field density, and that is, or the magnetic flux density, and that will be 5 times 10 raised to power minus 4 multiplied by V is the velocity. Sorry, I didn't write that value out. The velocity from the question. Sorry, we have the velocity from the question, and that is V. So the velocity is 1 times 10 raised to power 5 meter per second. So this is the velocity from the question. So now we have to multiply by the velocity, and that is 1 times 10 raised to power 5. And then finally multiply by Q, which is the charge. And the charge is 10 times 10 raised to power minus 6. So I'm going to say 10 times 10 raised to power minus 6. And that is the charge from the question. Then finally, we can now multiply these values. So 5 multiplied by 10 raised to power minus 4 multiplied by 1 times 10 raised to power 5 multiplied by 10 times 10 raised to power minus 6. All together, we can use our calculator to multiply out everything. And that will give us the force as 5 times 10 raised to power minus 4 Newton. And this is the force on the charge as the final answer. Please don't forget to like, share, and join for more videos like this. Thank you for watching.